Today we're going to talk about electron configuration. So when we do electron configurations, we have three major sublevels. We have four major sublevels: the S sublevel, the P sublevel, the D, and the F. So we have the S, P, D, and F. So the S only has one orbital, and each orbital holds two electrons. So therefore the S sublevel can only hold two electrons. So the S holds two, and the P has three sublevels, so it can hold 6 electrons. Sorry, the P sublevel has 6 orbitals, and each orbital holds 2. So since the P has 3, then 3 times 2 equals 6. So it can hold 6 electrons. And the D has 5 orbitals, so it could hold 10 electrons. And the F has 7 orbitals, so it could hold 14, since each orbital can hold 2 electrons. So that is our little chart we have there for reference. So I always think of these sublevels as buses when it comes to electron configuration. So when we do an electron configuration, let's say we have the easiest one would be hydrogen, of course. And since we start with the S orbital always, with the smallest bus in my terms, and since the S can hold 2 electrons, the S sublevel can hold 2 electrons, then what I think of it is that the S orbital, we have the first S orbital, and there's all the way up to 7 actually. So the first S orbital, so 1s, and then hydrogen takes up 1 seat in that bus. So you put a 1. So it would be 1s1. So in the same way, we could find an electron configuration for pretty much any element. So let's take neon, for example, which is a noble gas, since it has all of its valence shells filled to the max. So let's take neon. So neon has 10 electrons. So neon has 10 electrons. So let's put 10. So neon has 10 electrons. So let's say this bus right here is the S bus. Okay, so let's say it only has 2 seats. So let's say these seats are gone. Take this seat, these 3 seats out. Okay, so it's the S. So it only has 2 seats. So neon will fill up all of those 2 seats. So let's do that in red. Let's do that in red so it fills up all of this neon. Fills up these 2 seats. So we have to get the next bus in, the second S bus. So let's pull that one in. Okay, so we pull in the second S bus, so that could fit 2 as well. So we have 8 electrons left to fill. So we fill in those 2 spaces. That leaves us with 6 electrons left. So let's fill these 2 spaces up with neon. Okay, and now we have the P orbital. So I'll show you a chart later that shows basically later in this video exactly the order in which the electron configurations go. So after the 2s comes the 2p. So the 2p, if you remember, has 6, as in right here. So let's get a 6th bus. Our buses only have 5, so just imagine that they have 6, or I'll draw a 6th window. So I drew an extra window here. So neon has 6 electrons left, and the P bus has 6 seats, so it fills up all of those seats. So let's do that all in red. So all of those seats get filled up with neon. So therefore, let's count up the buses we used. We used 2 S buses to the max. So we had one S2, the first bus, and we used 2 seats in that. And then the second S bus right here. And then we used 2 seats in that. So one S2. So we used 2 seats in the 2S bus, so therefore our configuration is 1S2, 2S2, then we used all 6 seats in the P bus, and that was the first P bus, but we counted as second because that's where the P's start. So we get in the second period, so we get 2P6. So our electron configuration would be 1S1, 1S2, 2S2, and then go down a bit, 2P6. Okay, so that would be our configuration. So let me show you that chart with the directions in which you do the electron configuration. So this is basically the chart that we use to do electron configurations. So we start with the 1s, and then we keep going down until we have something to go horizontally. So we do 1s and then go down to 2s, and then go to 2p, finish out that row, go to the next row, go to 3s, 3p, 3d, go to 4s, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 7s, 7p, and I didn't add all the way to 7 for the d's and f's because you won't ever need to go that far, because you usually can abbreviate your electron configuration. So let's say if you do number 11 on the periodic table. So let's say we do 11 on the periodic table, sodium. In that case, we don't have to write out the full configuration, which would be 1s2, 2s2, 2p6, and 3s1. We want to, if that gets kind of long once you go to unaninium or a crazy element like that, or Einsteinium, your configurations could get pretty long. So if you go to the closest noble gas, so this configuration right here is, as we know, neon. So we could just abbreviate it and put neon in brackets, and then just do 3s1. So that would make it easier to do longer configurations. I hope you learned something in this video, and thank you for watching.